Okay, so now let's do this little bit different function. This isn't a rational function anymore because the this isn't a polynomial in the numerator. But we've been working a lot for ln of x, so I think it's important that we kind of revisit that. If you want to make yourself a quick little sketch, ln of x looks like this, where this is at 1, 0. Okay, so, but the same idea, we want to find what makes the numerator 0, and if it's a fraction, what makes the denominator 0 as well. So ln of x minus 1 equals 0, when ln of x is equal to 1. You may just know that's e. If you forget, you can change that to exponential form, and you can say, well, that means x is e to the first, which is e. So there's one special number. And the denominator is 0 when x is 4. So now we have our number line. Okay, so we know that we need to put 4 on our number line, and e is like 2.7 something, so e has to be to the left. And you have to be a little careful here too, because there won't be any points at 0 and to the left, because ln doesn't exist there, so you couldn't get an output. So this time we had a little different restriction. Okay, let's think. If you put e, you get the numerator 0. So just for me, I just make a little closed dot there. It shows me that I get 0 there. And if you put in 4, you don't get any output. Okay, so now we have two sections. Okay, and let's sort of do that strategy again. I like to make a template for my whatever function. This one's a little easier because I have only 2 factors. And I'm going to go grab a different color because colors are the best. This is my markers with you guys. Okay, so let's think about this factor. Okay, that was 0 when we were at e. If you pick a number bigger than e, like a really giant number, that'll be a giant number minus 1. So that'll be plus. And to the left where the function exists, that will be negative. So this is a plus for this factor, and this is a minus. Okay, and then we'll do the same thing. We'll teach crazy today. Okay, that's 0 when x is 4. Okay, let's sort of think about splitting the number line. If we pick a number bigger than 4, like a million minus 4 is a plus number. I get my screen hung up on me. Okay. That's a plus number. If you go to the left, that's a minus number. So this is plus, minus, minus. And we'll just sort of summarize that then. So if you divide 2 negatives, this is a plus. Okay, and then this would be a negative, and this would be a plus. And now actually let's answer the question. We didn't do it in the other one. It got a little crazy, but we can sort of answer this question now. I'm just going to grab a different color. Let's grab green. Okay, so where is it positive? In this region. Not here because there's no output. Not here because the output's 0. Everywhere in between. Okay, where else is it? Not here because this output is undefined, but everywhere to the right. So you can write that a couple different ways. So you can write that with inequalities. So x is between 0 and e, and x is bigger than 4. If you guys remember interval notations, you would write a strict inequality is an open parentheses. That's 0 to e, and 4 as far as you can go. Awesome. Okay, let's do one more. Okay. Oh, Miss Brady, hang on. I'll get you there. Hang on. Technology. Okay, so in calculus then, we're going to start looking at 2 functions. So we look at the last one, we're going to look at 2 functions. Okay, and our goal is we want to know where things have the same sign. So we're going to sort of modify our strategy a little bit, and we're going to write the 2 functions on 2 different lines. So this is a little preview. Okay, So on the top, we'll think about the velocity. And on the bottom, we'll think about the acceleration. And the same thing, we want to put the zeros in. So instead of having this velocity, let's factor it. I think it would be t minus 2, t minus 4. So 4 and 2 are important numbers. This, if you factored out, I think you'd have t minus 3. So 3 is an important number. So we've got 2, we've got 3, and we've got 4. And so I'm going to split the region. Okay. Okay, so let's see. So this, could you guys even just do this sort of graphically? That's a parabola. It opens up, or you could even just do, you could sort of think about it graphically, that this looks like this if you graph that parabola, but we'll use the same strategy. Okay, so we've got 2 for velocity. Here's my template. Okay, at 2, that's here. If I make it bigger, that's plus, 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 negative. And here would be at 4, so plus, negative, negative, negative. So this is a plus number, this is a negative number, this is a negative number, this is a plus number. Notice that would be the same if you just thought about it graphically. This parabola has intercepts at 2 and 4. It opens up, so to the right of 4 and to the left of 2, it's above the axis, which is positive. So that's another way to think about it. Okay, let me just grab a different color. Let's do orange again. Okay, so let's do acceleration. Okay, acceleration breaks at x is 3. It's a line with positive slope, right? If you go to this side, that'll be a plus number. And if you go to the other side, that'll be a negative number. Okay, and this time, what was our task? We want velocity and acceleration to have the same sign. So we're going to compare both those numbers. And let me highlight in green again. Okay, so in this slice, one's plus, one's minus, so we don't want that. In this slice, both functions have negative outputs. And in this slice, both functions have positive outputs. So we're looking at when t is between 2 and 3, and when t is bigger than 4. Yay!